Hello. Today is the first of our talks about how these two different epistemologies seek knowledge through research. And we'll start by examining quantitative research in the positivist tradition that searches for regularities that can be used to make predictions. This is far and away the most common form of positivist research. Certainly in the United States, it dominates the study of international relations at many universities. The search for correlation, of course, assumes that they can be used for purposes of prediction and explanation. That understanding cause is not essential. That cause can fundamentally be bypassed or finessed if we have robust regularities. I am not persuaded by this line of argument, especially in the field of international relations, which imposes almost insuperable obstacles to research of this kind. For a start, we have to be, or researchers have to be very clear about what they consider to be their independent and dependent variables. Independent variables are the factors that you think explain the outcome, like the onset of war that you're trying to explain. What you're trying to explain in turn is the dependent variable. One of the problems here is that all of these terms are subjective, sometimes even arbitrary in nature, for reasons that I noted in an earlier talk, that unlike temperature, which measures molecules, things like the balance of power, polarity, don't refer to anything real. Many of them are very hard to measure, and it's not surprising that scholars disagree among themselves as to what they are. This is true not only of independent variables, but of dependent variables. Consider the Democratic Peace Research Program, perhaps the most active research program in the liberal tradition in international relations. It makes the claim that democracies don't fight one another, that if you had a world of democracies, it would be peaceful. Quantitative researchers have tried to study this, and one of the big problems they've encountered is with the dependent variable. What's a democracy? And what counts for a democracy at what point in history? There's no agreement here, and even small differences in coding can have big effects in the outcome of the research. A related problem has to do with who codes, the analysts or the policymakers. In almost all of these studies, it's the analysts who decide what the situation was. Yet, in effect, it's the policymakers whose decisions count. Let me give you one example, the status quo. Thomas Schelling famously argued that in a crisis, states defending the status quo can more credibly make threats to use force than those who are challenging it. And the reason being that giving up on the status quo would be a bigger loss for the power defending it than making a gain would be for the state challenging it. he used the Cuban Missile Crisis as his example, arguing that it was one of the reasons the U.S. won, allegedly, a victory in that crisis. In point of fact, documents and interviews reveal that both the United States and the Soviet Union believed they were defending the status quo. They just defined it differently. The United States was preventing the Soviets from upsetting the strategic status quo by introducing nuclear-armed missiles into Cuba capable of reaching the United States. In Moscow, Khrushchev and his associates thought that they were defending the status quo because they were sending missiles into Cuba to prevent the United States, deter the United States from invading Cuba and overthrowing Castro. Both of them thought they had a bargaining advantage. One of the other big problems with quantitative research is in keeping with the positivist tradition. It is anchored in an understanding of causation that looks for the immediate trigger of an event, what's called inefficient causation. And modern science made great strides by rejecting notions of first cause, tracing it back to God, or today maybe to the Big Bang. Doesn't tell you much about the origins of war by tracing it back to the Big Bang. But it may tell you a lot going back several steps, because something like an arms race may be a reflection of a deeper set of causes, which may be the important things you want to study in trying to decide why wars occur. So quantitative studies risk mistaking superficial for fundamental causes. And what we really need to do is to consider multiple causes of wars and the ways they have interacted. But this opens another Pandora's box for quantitative research. Multivariate statistical analysis means having 2, 3, 4, 5, possibly 6 variables. If you do this, you need a very large number of cases to avoid having what statisticians call negative degrees of freedom. So let me explain this. If you have 2 variables and you're trying to explain war, you have a 2x2 matrix, and you therefore have 4 cells. If you have 20 cases, you might be able to flesh out relevant cells with enough cases to allow you to do a meaningful statistical analysis. Having 50 cases would be better. But if you have 5 variables and you're trying to decide how they're related to war and peace, you have 5 times 2, you have 10 cells, and you need many more cases. But there's a problem with large data sets in international relations, and it has to do with the need to have cases that are comparable and independent. This is a primary requirement for any kind of statistical analysis, and a condition that can readily be met, for example, by psychologists who are using students in experiments in labs and may have 100 and 200 students performing the experiment, none of them knowing how the others have performed. So they have a large number of independent cases, and they're comparable because they're students responding to a few simple cues in a controlled experiment. if we're studying something like wars, and I'll continue today with this example, we don't have that many of them. Since 1945, there have been fewer than 40 wars. If we go back to, let's say, 1914 or 1815, when the Napoleonic Wars ended, to put together a larger data set, we're beginning to compare apples and oranges. Even in the post-1945 period, we do this because some of these wars were, let's say, violent border conflicts that may have resulted in 1,000 deaths in comparison to major wars, let's say, between Iran and Iraq, that went on longer and resulted in hundreds of thousands of casualties. And as for independence, again, people learn, and policymakers and generals in particular learn about wars. They don't always learn the right lessons. One of the bromides of international relations is that diplomats try to prevent the last war, whilst generals prepare to fight it. Almost invariably, what worked or might have worked last time is not necessarily apropos to the current situation. But whether it's right or wrong, people learn, so these conflicts are not independent from one another. The experiences that people have, either personally or through reading, influence very much how they respond and how they prepare. So it's very hard to meet these various conditions necessary for quantitative research through multivariate analysis. There's another problem as well, and that is that the world, the physical world and the social world, are nonlinear and open-ended. So by open-ended, I mean that what happens in one domain, let's say international relations, can be influenced by what happens in other domains, economics, medicine, and this relationship will change over time. So consider the effects by economics, allegedly a science, to explain recessions. Their models rely primarily on economic variables, on the assumption that what happens in economics is most important to the causes of recessions. But in fact, if you look at a handful of recent recessions, you will find that their principal causes were outside of economics. The most recent example being the pandemic, which created an economic crisis that resembles in many ways the Great Depression of the 1930s in its severity. Part of what happened was economic in that manufacturers became efficient in their use of supply chains. Parts and materials arrived just as they were needed, so they didn't have to be stored. But the pandemic affected both the production and the transport of goods, creating havoc with supply chains. The failure to produce led to loss of jobs, and it accelerated and did so in a non-linear way. Linearity is when two factors come together and have an arithmetic effect. So whatever value each has, you add them together, and that's the consequence, your vector. In nonlinear interactions, these two factors that come together may have geometric effects and produce a sharp curve, or they may cancel each other out. And we don't know often beforehand which factors will be relevant and the extent to which they will be linear or nonlinear. All of this enormously complicates our research. It makes it possible, as I've argued repeatedly, to offer causal accounts, explanations of things that have happened, but not predictions. It also defies the creation or the finding of robust regularities that can be used for purposes of prediction. Finally, when we look at these kinds of data sets, when they're used for studying wars, we all know that wars have underlying and immediate causes. And immediate causes are the catalysts that set them in motion. Well, catalysts are not like trams or streetcars. They don't come along at a regular schedule. Sometimes they happen, sometimes they don't. If they don't appear, we don't have a war. Yet, the underlying conditions to bring about that war may well have been present. So, if we were using those in a data set without controlling for the presence or absence of immediate causes, we would be very misled by our findings. I have elaborated this elsewhere in a study of the origins of World War I, arguing that the catalyst, the assassinations at Sarajevo, were in fact a cause in their own right, because they met 5 conditions without which war wouldn't have occurred, and that it's almost impossible to imagine another catalyst that would have done this. So the relationship between immediate and underlying causes is a subject worth study in its own right, and one that confounds the use of even multivariate analysis for purposes of studying whether wars occur. The proof, of course, of all of this, as always, is in the pudding. The largest ongoing quantitative data project to study war is known as the Correlates of War. It started in 1962 at the University of Michigan. It's been going on for, almost 40 years. Its principal findings are that wars are most likely between states that share borders and that have territorial disputes. Well, think about this. Does it really pass what some might call the grandmother test? In other words, would your grandmother know this without having to take a university course? But most important for our purposes, lots of states share borders and don't go to war. Lots of states share borders and have border conflicts that don't go to war. Having this knowledge can't be used for purposes of prediction because you have so many political units that meet the conditions that don't go to war. In fact, to understand these cases and the difference between the outcomes of war and no war, one has to go into context and look at other factors and indeed roll up your sleeves, study history, see what is idiosyncratic or particular about different situations. This suggests that theories of any kind are really starting points for more fine-grained narratives. Before I end, I want you just to take a look at my peonies, which are opening. I'm in New Hampshire. It's very late June, and our flowers are finally coming out. Have a good day, and thank you very much.